Hello my dear students, good afternoon. Previously we discussed about Reamer-Tiemann's reaction. So what I was given, I'll just recap. Just only two reactions we have after this. One is coal-based electrolysis as well as Fry's rearrangement. C6H5OH phenol when react with a chloroform CHCl3 in presence of base like sodium hydroxide or KOH like that, and you will get salicylaldehyde. I told you C6H5OH you are having, along with that CHO you have salicylaldehyde. Okay, so chloroform you have. In this I was given who is the electrophile. CCl2 is the electrophile. Okay, and if you use CCl4 instead of CHCl3, if you use CCl4, then what is the product I was given there? What is the product? Instead of CHO, you will get COOH there. Correct? So let's see the mechanism here. What happens? First, CHCl3 in presence of base you are using, no? So base, take it as OH minus or any OH you take, not a problem. Okay, so what happens? CCl3 minus plus H2O. OH minus, base subtract the proton from here. Understanding? Because Cl, Cl, Cl and H like this. CCl3 H like this. H plus gone, so C minus. So CCl3 minus. So from CCl3 minus, again you will lose Cl minus by using the same on hydrolysis. You will get CCl2 dichlorocarbene plus Cl minus you are having, because Na plus is there, no? Na plus and Cl minus, NaOH will go, like base hydrolysis we call this, and this is the electrophile. Who is the electrophile? I was given already. CCl2 is the electrophile. Dichlorocarbene is the electrophile. Why it is electrophile? I told you that also. Carbon has 2 chlorines and 1 electron pair. Total 3 pairs only present. 3 pairs means 3 2s are 6 electrons. So here now what happens? On phenol I write here C6H5 and OH. Okay. So now what happens? Phenol, so phenoxide ion, actually phenol with sodium hydroxide, phenoxide ion you will have. Okay, so when this bond is like this is a benzene, and now what happens? This CCl2, suppose if you take phenoxide C6H5O minus, because base abstract the proton from here, phenoxide ion it is. Now what happens? If this come over here and this will migrate like this, then what happens? This carbon gets negative charge or not? So if you take phenol also, not a problem, but phenol with base, it will, this proton taken by base, because phenols have acidic character, I told or not, acid donate proton or not. So that's why phenoxide ion I taken. Don't get confused. Phenoxide ion CCl2. This carbon gets what charge now? Negative charge. And here this carbon is electron deficient. Don't think this lone pair will donate here. Okay, this negative charge will negative charge will transfer to this carbon actually now. So by using this lone pair, here it form a bond. This negative charge transfer to carbon. So just have a look and double bond O, and you are having Cl and Cl here. Understood? And this carbon gets what charge, sir? Now negative charge. What I said, understood? These pi electrons are moving over here. This negative charge transfer to carbon by using this lone pair and form a new bond. Actually here hydrogen also present, no? Here like this. Hydrogen also present or not here? Every carbon has hydrogen or not on benzene, except this, because oxygen is there here. Because here OH is there. So here no hydrogen except this. Here one hydrogen, here one hydrogen, here one hydrogen, here and here you have hydrogen. So what happens next? This hydrogen will transfer here, going back. So next what happens means, now you will have this one C6H5. Now again double bond, because this CH bond is breaking or not. Able to see what I written here? So just H you have. This bond, CH bond breaking. So double bond here. So if double bond means carbon gets 5 bonds, no? So this pi bond only, this pi bond will migrate towards oxygen. So it will be O minus now. Now this group will be CH. This hydrogen will remove as H plus, no? This H plus, and carbon got what charge? Carbon have what charge here? Carbon have negative charge here. So H plus and C minus. So you are having CH and Cl like this. Understood or not? So for phenol, phenoxide ion will form. From phenol, phenoxide ion will form. For phenoxide ion you are adding CCl2. CCl2 is the electrophile. After addition this becomes CCl2 minus, because it has already 3 bonds. One more new bond was formed. So 3 bonds in that, one is negative charge, and this bond will, CH bond will break. So new pi bond will form here. This double bond O will become single bond O minus, because these pi electrons migrating towards oxygen. Now you are having this. So next what happens? This next step, from here I will write. So I will write again that. So C6H5, and now, and this is O minus, and CH and Cl and Cl. Hydrolysis, H2. Hydrolysis happen. So what happens next on hydrolysis? You will have C6H5. On hydrolysis here also one H plus will come. So it will become OH. Now CH. Cl instead on hydrolysis. CH. Here OH and here OH. So I told you, do you remember or not? For dihalo compounds, if 2 hydroxy groups are there, water molecule will go minus H2. Do you remember this? Minus H2. Certainly our final product is C6H5 and OH. Water gone, no? OH and H gone. So CH double bond O. That means CH double bond O you got. This is called salicylate. See this one and this one same or different? C6H4 OH and CHO. OH and CHO. Now it's not C6H5, C6H4, because one more hydrogen also removed here. So it became OH and CHO. C6H4 OH and CHO. This is called salicylaldehyde. Okay, this is the mechanism. In mechanism what happens? Everybody please remember, in mechanism what happened? This chloroform abstract proton. So from chloroform, proton abstracted by base CCl3 minus, CCl3 minus converted to CCl2, CCl2 attack happened. This is the total mechanism. So have a screenshot and write down this mechanism. Okay, so this is about the Rimmer reaction. Understood, sir? So next we have to discuss about Mr. coal-base electrolysis. Very simple. Coal-base reaction, simply, not electrolysis. Coal-base reaction. Coal-base electrolysis means calcium salts or carboxylic acids, those actually. Okay, in alkenes, there you have. Got it, sir? Now we have to discuss about coal-base reaction. Coal-base reaction is very simple. Phenol, for that C6H5OH, for that we will add carbon dioxide followed by hydrolysis in presence of base hydrolysis. Okay, now you will have what C6H5 and OH, and here C double bond OH. What happening here? You are having salicylic acid. Salicylic acid you are having in coal-base reaction. Phenol, CO2, salicylic acid. Got it? So no need of mechanisms like that. Salicylic acid is the product. Phenol react with carbon dioxide. That's it. Okay? Very simple actually. C double bond O, double bond O. Mechanism if you want means, if this migrate over here, carbon gets what charge? Positive charge. Oxygen gets negative charge. These bonds have to migrate like this. Of course, this become O minus and double bond will come. Lone pair will come, no. This will come over here. Here negative charge. Getting what I am saying? Here it is lone pair, no. Lone pair will come over here. This will come over here. C minus, and this carbon gets positive charge, plus charge, because O minus. So this C plus will add on this. Got it? On hydrolysis that converts to COOH. That's it. Okay. So this is about coal-based reaction. Next, Fry's rearrangement. Fry's rearrangement. Okay. Acetophenol. Do you know acetophenol? Like C double bond O C double bond O CH3. Phenyl acetate. Acetophenol means ketone actually. Sorry, it is ester. CH3 Cu double bond O. This is C6H5. Okay, C6H5 O COCH3. Very simple. On rearrangement in presence of anhydrous AlCl3, rearrangement happens. This is one of the example for types of organic reactions: additions, substitution, eliminations, and rearrangement. Without changing the molecular formula, here group will rearrange. Actually, how this hydrogen and this group will rearrange. This hydrogen or para position hydrogen. So why not this hydrogen? Don't ask me. Okay, because these two hydrogens are identical. This or either this or this. So why not meta? You are saying because this is the electron pair donor. Means negative charge you will get either at ortho position or at para position only. That's why the rearrangement won't happen at meta position, because this, if breaking like this, C plus here. Here also very important, who is the electrophile? They will ask you. Electrophile is CH3 C double bond O plus. CH3 C double bond O plus. Understanding? CH3 C double bond O plus is the electrophile. So this positive group can add at what positions? Either at ortho position or either at para position only. Following everyone? So this is very very important. So COC3. So this O has the single bond oxygen means, I told you, single bond oxygen means having lone pair. Double bond oxygen means that double bond oxygen means having but cannot undergo either donation again. Okay, so single bonded oxygen if there, that is ortho para directing group. So following everyone? C6H5, like this you have C double bond O. This oxygen cannot donate now. Why? Double bond oxygen cannot donate. Always single bond oxygen only can donate lone pair, because oxygen can form maximum 2 bonds purely. Of course, one double bond and day 2 bond is possible, but within 2 atoms like triple bond is not possible for oxygen. So double bonded oxygens won't donate electron pair, so single bond oxygen donate electron pair. So pi electrons will migrate either towards ortho or else at para. Understood? So you have negative charge either at ortho, either at para. So rearrangement happens. So rearrangement happens at where? At ortho or para. Which group will rearrange? CH3CO group will rearrange with hydrogen. So hydrogen will go there and COCH3 will come here, either at ortho or at para. So what is the product here? Final product C6H5. C6H5. It will become OH and this COCH3. Or at para, C6H5 and OH and C double bond O CH3. What happens? This COCH3 group and hydrogen rearranged, and this ortho is major actually, because rearrangement at side carbon is very simple. Here means here to here and here to here, 2 migrations must happen. So para is difficult, ortho is easy. So this compound you will have phenyl acetate converted to 2-hydroxy acetophenol. Acetophenol, hydroxy, 2-hydroxy acetophenol, 4-hydroxy acetophenol. Remember names. Understanding? So very very important. They ask names. So it's hydroxy acetophenol is the product. Hydroxy acetophenone is the product. This one. But it will do what position? Second position. Hydroxy, this is called aceto group, CH3CO. Okay, acetophenone we call it. This is 4-hydroxy acetophenone. Acetophenone, Y-one ketone. So this is about the Fry's rearrangement and cold base. Next, just 3 uses of phenols you have to understand. So it is used in the preparation of important dyes and drugs and pharmaceuticals, and one, and Dettol formula. Dettol is antiseptic, and 2,4-dichloro 3,5-dimethyl, because it is 1, 2, 3, 4, 5 positions. I have no need to write, but just for understanding, 1, 3, 4, 5 and 6. So 2,4-dichloro and 3,5-dimethyl phenol is what Dettol that is called, and 0.2% aqueous phenol is antiseptic, and phenol is also used in many polymers preparation. Okay, phenol with formaldehyde, like phenol with urea. So there are so many what we call condensation polymers can be prepared by using this phenol. Okay, phenol, how to prepare dyes we will understand in benzene diazonium chloride. Benzene diazonium chloride react with phenol and form dyes, that we will have in benzene diazonium chloride properties. Okay, just simply now remember how dyes form means benzene diazonium chloride with phenol. Okay, so in that way you will get dyes like that. If you want, I will write right now only like this: C6H5 N double bond N and N plus and Cl minus, like this. Okay, and phenol means C6H5 OH, and here you have hydrogen. So this hydrogen and Cl will go, N2 plus and Cl minus. Okay, so N2 plus and Cl minus. Now you have between these two, nitrogen and carbon, you have a bond. Para position only. Okay, para hydrogen will go. Now what is the product here? This diazonium chloride C6H5 and N double bond N, and this is a di. Okay, so this is very important, and those names also we will discuss later on, don't worry. So because nitro compounds we have one of the topics, so have a screenshot and write down notes. So that is a very important. Okay, so one more important thing, that is phenols are there. No, phenols are carboxylic acids. Sorry, phenols with carboxylic acids or alcohols with carboxylic acids gives esters. Like alkyl halide with sodium alkoxide gives ether. Suppose, do you remember this? CH3, CH2, Cl plus NaO, CH2, CH3. What is the name of this reaction? Williamson synthesis. NaCl will go. Do you remember this reaction? Ethyl chloride with sodium ethoxide. Sodium alkoxide in general. Sodium alkoxide. Sodium ethoxide with ethyl chloride. NaCl will go, ether you are having. What is the product here? Like this: CH3, CH2, O, CH2, CH3. Many exceptional cases also I was given. If the alkyl halide is tertiary, alkene is the product, like that. So here in same manner, between alcohols and carboxylic acids, you will have the same type of reaction. Suppose here CH3, CH2OH. One react with, suppose, C double bond O, OH and CH3. Okay, so now what happens? This is a strong acid than this. Strength of acids here. This is more acidic than this. Relative strength of acids, if you want, first carboxylic acid. Carboxylic acids are more acidic. Carboxylic acids, then carbonic acid. Do you know carbonic acid formula? Carbonic acid, HCO3, and then phenol. Phenol, then more acidic means actually methanol, methanol then water. Okay, of course, methanol after remain alcohol simply. Why methanol? Alcohols are more acidic. Alcohols are more acidic even than water actually. So these are very important. So here what happens here in this is the order of acidic nature. Why I said here this alcohol when react with carboxylic acid, which type of bond will break? This CO bond will break or OH bond will break? They'll ask you. From alcohol CO bond will break. This is very important. In alcohols OH bond if break, if you said that is wrong, they'll ask you which statement is correct. During when alcohol react with the carboxylic acid, which statement is correct? In that reaction, OH bond cleavage in alcohol takes place is wrong. CO bond cleavage in alcohol takes place is correct. So OH from here and H from here go. Why H from carboxylic acid gone, sir? Because carboxylic acids are more acidic. That's why. So here what happens means here ester will form, that is CH3 and CH2 and O, C double bond O, CH3 you are having. CH3 CH2 O, C double bond O, CH3 you are having. This is what ester. Even phenols can involve in same kind of reaction. If you take phenol C6H5OH when react with some carboxylic acid CH3 C double bond OH, if you take, what happens here? Here OH from here and H from here will go. Now the reaction is like this, C6H5 and O, C double bond O, CH3 are having. Okay, so here this kind of reactions happen. These are very important, please remember. And we will enter into carbonyl compounds. Carbonyl compounds means both aldehydes and ketone. So you remember the order: carboxylic acids are more acidic than carbonic acid. Carbonic acids after phenols, phenols after methanol, methanol means alcohols, and afterwards least acidic is water. Okay. So water, no, actually sorry, water is more acidic than alcohols. I told you this one, so I given wrong. So first carboxylic acids, then carbonic, this one is correct, carbonic acid, and then phenols. Phenols are more acidic than water than alcohols. This is correct. And only methanol maybe have somewhat more acidic character, but water is more acidic than even ethyl alcohol like C2H5OH, like that if you take, than ethanol, water is more acidic. This is important point, please remember all these things. And next we will start carbonyl compounds. Carbonyl compounds means what? Aldehydes and ketones. Maximum of the reactions, especially preparations, are well known for us. Why preparations are known? Because just in alcohols we discussed, primary alcohols on oxidation gives aldehydes. If you use mild oxidizing agents, am I given or not? Secondary alcohols gives ketones, even copper by 300 degrees Celsius. Those all are very important. But carbonyl compounds means both aldehydes and ketones. It is somewhat chemical properties are more. Those many named reactions will come like aldol, condensation, Cannizzaro. There are many like Clemmensen reduction, Wolff-Keshner reduction. So all some named reactions will come in this, and many exceptional cases will come. So listen carefully, but freshly tomorrow I'll start that chapter. Okay, what is that chapter? Carbonyl compounds or aldehydes and ketones. Thank you.